Bismillah. In this video, we will study integration of the trigonometric functions. We studied before the rules of the differentiation. Differentiation of sine, for example, is cosine. And also we studied that integration is the opposite process of differentiation. If I integrate the answer, integration of cosine, I have to get sine. So that's why the rule of integration of cosine is sine and divide by a, which is the differentiation of the angle. Same thing goes for the next. Differentiation of cosine is negative sine. If I integrate the answer, this minus will come here, and the integration of sine is minus cosine ax. And that's also true for the rest of the functions. So the rules from number 1 to number 6 in the blue box are called the standard rules, while the rules in the red box, number 1, 2, 3, and 4, need to be proved. And inshallah we will prove them inshallah later, but now I need you just to memorize them. Okay, in front of you in this screen we have how many boxes? We have 6 boxes. As you can see. The blue and the red, the colored ones, are the rules of the integration for the trigonometric ratios or functions, while this box is the rules of the differentiation. But this box and this box, they are called the trigonometric identities, and you should have studied them before in grade 11 in AS level math. Okay, and they are really easy and you will need them the most. And the last box we studied before, it is from the basic integration rules. Okay, how can we use these boxes, all of these rules, to answer our questions? The question number 1 says, calculate each of the following integrals. The first thing, integration of sine 7a. What is the integration of sine? The integration of sine is minus cosine. So the answer is minus cosine, same angle, but you have to divide by the 7, which is the differentiation of 7x, plus the integration of cosec squared. Do we have a rule for that? Yes, this is it. It's rule number 4. Cosec squared, what is the integration of it? It is minus cotan. So it is minus cotan, same angle, we don't change the angle, divide by 3, which is the differentiation of the angle, plus c. Of course, you know that plus minus, this plus minus will be minus, so the answer is this. Okay, go to the next question. In the next question, as you can see, 1 over cosine squared. Do we have a rule for that? Do we have a rule for 1 over cosine squared? There is no rule. No rule whatsoever. So what should I do? I must use the trigonometric ratios or identities. You see here that 1 over cosine is sec. So this will be integration of sec, because 1 over cosine squared is 6 squared x dx. Now, after I did this step, my question, do we have a rule for integration of 6 squared? Yes, we do. Where is that? This is it. It's rule number 3. What is the integration of 6 squared? It is tan. So it is tan x plus c. The next question. Do we have a rule, a standard rule for 1 over tan x cosine squared x. We don't have. So I have to change it. We said that 1 over cosine squared is 6 squared according to this rule. So this will be written as integration of sec squared x, which is 1 over cosine squared, over tan, I don't touch it, tan x, we don't touch it, dx. Now, I need you to notice that from this rule, that differentiation of tan is 6 squared. Differentiation of tan is 6 squared. So this is f dash and this is f. And according to this rule, the differentiation of integration, of f dash over f is ln f. So the answer here is going to be ln f. What is the f in this question? It is tan x. So it is ln tan x plus c. Question 4. Integration of cosine squared. Is there any rule for that? There is no. But we have a rule for cosine squared. Where is this? It is here. I can write integration. Then instead of writing cosine squared, I will write half bracket 1 plus cosine 2x dx. Now take the half out because it's a constant, it's a number. Bracket. What is the integration of 1? It is x. It is x plus. What is the integration of cosine? It is here, the first rule. Cosine is sine, so it is sine 2x over 2 plus c. Question 5. There is no integration for sine squared, so I will have to use rule number 2. Sine squared is half bracket 1 minus cosine, double the angle. We double the angle. So this will be half bracket 1 minus cosine 2x. Okay, now it's ready. The answer is going to be half integration of 1 is x minus integration of cosine is sine 2x over 2 plus c. Number 6. Integration of cosine squared minus sine squared. Where is that? This is it. It's rule number 3. I'm using every single rule and I'm giving an example for each one so it can be clear. I hope that it is clear for you. So cosine squared x minus sine squared x is equal to cosine 2x. So this will be integration of cosine 2x. Why I'm doing that? Because I don't have a rule for cosine squared minus sine squared. There is no rule here. There is no rule, no integration rule for it. But I have a rule for cosine 2x. What is the rule of integration of cosine 2x? It is sine 2x over 2 plus c. The next, rule number 4. Cosine squared plus sine squared. This is it. It is 1. So what is the integration of 1? It is x plus c. Okay, there is no rule for tan squared. You can see that there is no integration rule for tan squared. But I can write tan squared by using rule number 5 here as 6 squared x minus 1 dx. Okay, what is the integration of 6 squared? It is here, number 3. 6 squared is tan. So this will be tan x minus. What is the integration of 1? It is x plus c. The last thing, question number 9, it is cotan squared. There is no rule for cotan squared, but we have a rule for the cotan squared trigonometric identity. I can write it. I can substitute it by cosec squared x minus 1 dx. Now cosec squared integration cosec squared has a rule which is number 4. It will be minus cotan x, okay, minus x, because differentiation of 1 is x, okay, plus c. So when you try to solve or to find integration of anything, you just see, do we have a standard rule for it? If it is that way, okay. If it is not, you will try to substitute it by anything similar to the standard rules. I hope that you understood. It is a little bit long, but do the video again, watch it again and again. Inshallah, you will understand. Thank you for watching this video.